Welcome you all to the LabVIEW programming environment video tutorial 2. Today we are going to see and understand Dataflow programming, tools palette, debugging tools, case structures and many more features of LabVIEW and its tools. Stay tuned and follow the instructions to learn this programming software faster. Let's begin. We will start with our second program on how Dataflow programming works with LabVIEW. In the front panel, I have got two objects. One is a slider and one is a thermometer. So slider, I'll show you how I have got the slider. Right click on the front panel, you will get the controls palette, go to numeric and vertical pointer slide. So that is the slider which I have connected it over here, and the thermometer. Right click again on the front panel, you get the controls palette and go to numeric and you can find the thermometer down here. So that is how you can select the slider and the thermometer. Of course, one more thing you can see down here, there is a digital data. To get the digital data, you have to right click on the thermometer slider, go to visible item and digital display. So that is the same way for both the temperature slider and the thermometer. Right, now on the right hand side you can see the corresponding terminals of temperature slider and the thermometer display. If I want to pass data between the slider and the thermometer, I need to wire it in block diagram. Now let us connect the temperature slider and the thermometer through a wire. So the left click, drag and drop at the thermometer and it gets connected. Now let us see what will happen if I press the run button. So I'm going to press the run button over here, run. You can see that the corresponding value change has come in a thermometer. Let me just try moving this temperature. You won't be able to see a corresponding change in thermometer. Why? Because when you click the run button, it will execute only once. After that, the program doesn't get executed, or the Dataflow program doesn't get executed, and you won't find the corresponding change in the thermometer. So as I've told you before, if you want to run continuously, if you want to see the data flow when you continuously move the slider in the thermometer, you have got to press this run continuously button. If you press the run continuously button, you will be able to monitor the continuous change in the thermometer. Right. So now if you have noticed, I have labeled temperature slider in degree Fahrenheit and thermometer in degree Celsius. Let us see the equation to convert degree Fahrenheit to degree Celsius. The equation is C equal to F minus 32 multiplied by 5 whole divided by 9. So that is the equation to get centigrade or Celsius from degree Fahrenheit. Now let us see how we can modify the program in the block diagram to accommodate the equation such that corresponding degree Celsius is being displayed by the thermometer with respect to the degree Fahrenheit from the temperature slider. To write our program to convert this temperature in Fahrenheit to temperature in degree Celsius, first let us remove this wire which we have already connected. When the pointer is shown there, you can click on that and it can be deleted by pressing the delete button. Right, now the wire is removed. Now let us get some mathematical operations as per the equation which you can see over here. The same mathematical operation is what we are going to use so that the temperature in degree Fahrenheit can be converted into temperature in degree Celsius. Right, so for getting that, let us right click, go to numeric, and you can see that all mathematical operations are out there. You have got add, subtract, multiply, divide. So a lot of other operations are there. You can also pin this by clicking on this button over here. You can pin this particular control palette so that you can access multiple things at the same time. Right, so you need one divider, you need one subtract, and you need one multiplier. So those are the three operations which you need for your mathematical operation. Let us put on the block diagram and then just remove this. Right, so let us put this apart. So first, as you know that it is F minus 32, F minus 32. So this is the first terminal which comes in. So F minus 30, let us program now F minus 30. This is F, left click and connect it to the one of the terminal of the subtract function. Click on that. Right, so one of the terminal is connected. The first function is F minus 32. You can take your cursor closer to this button. You can see that orange gets highlighted and the wire spool comes in picture. Right click and you can create a constant over the constant which is 32. So let us write 32 in done. So f minus 32 is done. So after that, f minus 32 you have got to multiply by 5 divided by 8. So let us connect it to multiplier. Yes, it has been connected to multiplier. So what it has got to multiply? It has got to multiply 5 divided by 8. So a division must happen here. That is why division operation is over here. Take your cursor to the top part of the input button and right click and create a constant. Term it as 5. The second one, you can again take your cursor to the second input button, right click, create constant, and that would be 9. So you can see that the division operation is ready and the subtraction operation is also ready. One of the division operation will come to the multiplier. So the multiplier inputs are ready and the output of the multiplier will go to our thermometer. Right. So our program is ready with the function f minus 32 multiplied by 5 divided by 9. Let us now see running this program. Let us do it using run continuously, and you can see that a corresponding change has already come in, and when it is around 80 degree Fahrenheit, the temperature has gone to 27 degrees Celsius. So this is a formula for converting temperature in degree Fahrenheit to temperature in degrees Celsius. Right. This programming in LabVIEW is called Dataflow programming, as the programming depends on the flow of data from one input function to another. So here in this scenario, this multiplier function will depend on this subtract function and the division function for it to perform. So it means that this multiplier function will be waiting for the subtract function and the division function to give its output. So unless the multiplier function gets its input, it will never be able to give its output. So it will be always in a waiting stage till it receives the input. Only then the multiplier will be able to process its data and give an output. This programming method is called Dataflow programming. Unlike the traditional language like C, C++, which is a text-based programming language, which is a sequential programming which runs from the top to bottom. With LabVIEW, it is all based on how things are arranged together, and that's why it is called data flow programming. So to have a better understanding of this data flow programming, let us use a debugging tool. This highlight execution is a debugging tool. What is a debugging tool? Debugging tool is normally used to check for any errors present in our program while it is running. So I can click on this debugging tool, and if I click on this debugging tool, my whole program will run very slowly such that I will be able to understand what is the data flow. Let us see that and try to execute it. Right, now I have pressed the highlight button and let me run this program continuously. Right, so you can see that this data flow is happening over here, subtraction is happening, division is happening, and only when the multiplier gets an input, only then the data goes to the output. Also you can see that when I move, it doesn't move very fast at the thermometer side, it goes only very slow because the system is running slower for us to understand about the data flow. So this also gives a better idea for us to understand and check or watch how things are flowing, how data is flowing, and check whether there are any errors in the program. So this is a very important debugging tool, the highlight execution button, which you can use at different places of your program. Now let us modify this program by adding a loop. So as I've indicated before, we were running it now with this run continuous for making it to operate continuously, wherein which I change at the input. You can see that continuously it gets operated. Now how to do that with the run mode? So that run mode is the mode which we normally use, and if I want to run things continuously, run the program continuously, even in the run mode, we have got to put a loop in the program. So how do I get a loop? Let me right click on the block diagram. You can see over here the first one which comes is structures. So in that you can see for loop, while loop, case structures, many other components. Major components which we normally use are while loop first importance, then we will most often will be using case structures, at many places we will be using for loops. So those are the three important structures which are very important to us. For now let us click on while loop, left click, and now click on the screen, drag across your program. So there you are, a while loop has been already set now, but the while loop is not complete. So for completing the while loop, we have got to put this stop. There is a stop button over here which is called a loop condition. We have got to right click on that stop button and create a control. So what does that mean? So it is nothing but a control button. You can see in the front panel a control button has come in place, which is nothing but a stop button. So if you are running the program continuously, the system requires you to provide a stop button such that you are able to stop it at any point of the time through the program. So now the program is ready. Before the stop button was connected, let us see a few things here. Let me delete this. This is an unconnected wire. Always when if you have connected unconnected wire, or if you have connected two different data types with a wire, so this type of red cross will be seen. You can double click it and delete it. This was the while loop when we have connected. You can see over here when you see the run button, it is broken. So that means that there is some error in your program. So let us click on the broken run button to see the errors. You can see that while loop conditional terminal is not wired. So when I click on that, you can see that it comes to the while loop. So conditional terminal is not wired. What does that mean? This is the conditional terminal, the stop button. So you have got to right click on the stop button, create a control. So once you have done that, you can see that the run button has come in active, and now you can start running your program. So stop button is mandatory for a while loop, because while itself tells that unlimited loop. So there must be some technique of coming out of the program. So stop button is mandatory for a while loop. Here you can see one more small button, I. I stands for iteration. So this also you can use it for some purpose inside the program by taking output from this. Iteration indicates, or it's an integer value which counts the number of loops it is being taken. It means that after the first loop, the value of I will be 1, and after the second loop, value will be 2. So it goes on like that. So it is the number of iteration which this while loop is doing. So this will be useful at many places for us to know how to modify the program at different scenarios. Right. We can also add some delay in this program. We can right click, go to timer and go to wait millisecond. So you can click on wait millisecond, and then at the input you can create a constant and give 1000 value. That means that there is a wait of 1 second. So time value is always represented in milliseconds here. So I have given 1000 millisecond. It represents 1 second. What does that mean? It means that the loop will get executed only once in every second. Still you can see that when I run it, it is little slow because it is getting updated. The output value is getting updated only after every 1 second. So that's why you can still feel it is little slow. I can even reduce it from 1 second to might be 500 milliseconds, so that it will be little more faster. So if I want at any time the loop to be slower, I can use this function. Now let us see another format of this, that is here we have used while loop. Let us now use for loop. So how do we do that? Yes, I have already shown you that at the structures there are while loop, for loop and case structures. Now let us see, instead of taking for loop from there, we can directly change this while loop. Right click on this while loop, you can change it to replace with for loop. So when I click on this, a for loop comes in picture. Now the for loop is there, but for loop doesn't need a stop button. So you can remove that. Right. Stop button is removed. So then how a for loop works? For loop has got fixed number of sequences. So where do I give the fixed number of sequences? Here, n. At this n button, you can see that it is written loop count. So you have got to give here the count value. So if I give right click on it and I create a constant and give 10 inside it, that means that whatever be there inside this function will get executed 10 times, and after that it will come out. So you don't need normally a stop button, because after a certain while it comes out. So whatever be the count value you have given, it only get executed. The whole program gets repeatedly executed only 10 times, and after that it comes out. While in while loop it was infinite while loop, there was no condition to be inside. So for that reason you need a stop button in a while loop. Now let us see how a case structure works. This is while loop again, back to its place. Let us now right click and go to structures and click on the case structure, and let us put it at the place where the case structure needs to be. Click, left click, drag and enclose all of those functions which need to come under the case structure and release it. Case structure is something related to switch statement in C programming. So in C programming we do have if-else statements, switch statements, which has got almost similar functions. Switch function is more professionally used, and case structure is similar to a switch statement. Here when you open up a case structure, normally you will have true false statement. You can see that now presently the code inside this case structure is true, and if I click on this false, you will be able to see that there is nothing inside it. That means that when there is a false condition happening, no program will get executed. So let us see what we can do here. For true and false statement, we need a press button or a boolean operator which can change from true to false. For that we would turn on a boolean from here. Let us use this vertical toggle switch over here. Let us connect that, make it a little bigger. Okay, so that is boolean operator, or which is nothing but a toggle switch. Let us put it over here and then connect it to the green button which you can see over there. Right, so that is connected now. There are two conditions, one is true and another one is false. Here you can see that there is nothing wired inside the false condition. Let us wire this false condition. Right, so there you are. So it has been wired. For false condition is that the temperature degree Fahrenheit will be directly connected to degree Celsius. Let us see what will happen now. We'll click the run button. Now you can see that the value on the slide at temperature degree Fahrenheit is equal to temperature in degree Celsius. Why? Because it is the false condition. When I click on this button, you can see that it has again come back to the original position of temperature in degree Fahrenheit to be converted to degree Celsius. So that is a case structure. You can still increase the level of a case structure, like changing this boolean value to a numerical value, and you can extend this case structure from 2 cases to might be 10 or 15 cases depending on your requirement. So how do you do that? So for doing that, let us remove this boolean from here, and we will wire a numerical control to it. So when I put a numerical control and a wire to the green button, you can see the green button over here to the numerical control. The green button has been changed back to the orange button, which is a floating point number. You can see that it has now changed to 0 and 1. You can also increase the number of cases, like right clicking on this and add case after. Once I press this, you will see that there are 3 conditions. Now 0th condition was it is directly connected. First condition is that our program was come in picture, and we have also got a second condition. In the second condition, let us create a constant. Right click, create a constant. So let it be 60. So what does that mean is when 2 number which comes through this numeric value, if I enter 2, this particular condition will come in and 60 will be the output. When I give 1 at the numerical input, this program will run and degree Fahrenheit will be converted to degree Celsius. And when I give it 0 value, let us see what is it, 0 value, directly degree Fahrenheit will be connected to degree Celsius. Let us see that modification. I am running it. As you can see in the block diagram, 0 is directly the input will be the same as output. In the 1 condition, let us see what is 1 condition. In the 1 condition, it must be program running perfectly well from degree Fahrenheit to degree Celsius. You can see that. And in number 2, numerical value 2, you can see that the output is not changing. It is being fixed to a particular value. So that is all about case structure. That's the end of this tutorial. Hope all of you have enjoyed watching this video. Let's meet again in my next tutorial. All the best for your online learning session. Thank you.